The shaded region in the diagram below is bounded by the x-axis and the curve y equals 2x minus x squared. The shaded region is rotated about the line x equals 4 to form a solid. Determine the volume of the solid. So it's going to be quite a long video, this one, because I'm going to do this using the cylindrical disc method that we've just discussed, also known as the shell method. I've seen that in literature as well. And then I'm going to do it by a more traditional rotate around the y-axis sort of method as well, to show that we get the same result. Whichever way I'm going to do it, I'm going to change the problem that we have here slightly, because we'd really like this to be rotated around the y-axis rather than the line x equals 4. And I can do this just by translating the situation 4 units to the left. So in other words, producing a parabola that goes through -4 and -2. Now what might strike you as well is if we have this area rotated around, and we're going to go around the y-axis because we moved everything 4 units this way, is that what I could do is use this area instead. And it definitely works better with the area to the right. You end up with a negative result if you do it with the one to the left. Doesn't matter, you can ignore the negative, but hopefully you follow that. What I've done is I've moved 4 units that way, and then just used the symmetry to do this curve over here. Now, what's the equation of that one? Well, it's going to be y is negative x minus 2, x minus 4. So that's going to be negative x squared minus 6x plus 8. And so we have minus x squared plus 6x, take away 8. And that's the curve that we're going to work with. So let's go ahead and use the cylindrical disc method. And that gives us that volume is 2 pi times the integral from 2 to 4 of x times negative x squared plus 6x take away 8 dx. So that's 2 pi times the integral from 2 to 4 of negative x cubed plus 6x squared minus 8x dx. Now, we know how to do that integral, so I've just gone ahead and found the result from that, and it ends up being 8 pi. So it's 8 pi cubic units. So how else could we have done this? Well, remember that we have this quadratic, and we have the intercepts at 2 and 4. And that means that x equals 3 would be the line of symmetry there. So we have y is equal to negative x squared plus 6x take away 8. That gives me x squared minus 6x plus 8 plus y is equal to 0. So, using the quadratic formula, x is going to be 6 plus or minus the square root of negative 6 squared is 36. Take away 4, 8 plus y, all divided by 2 times 1, which is just 2. And that is going to be that x is equal to 6 plus or minus the square root of 4 minus 4y divided by 2. So x is going to be 6 plus or minus 2 root 1 minus y all over 2. So that is going to be 3 plus or minus root 1 minus y. And that means, if we look back at our graph here, that this limb is going to be x is equal to 3 plus root 1 minus y. And the other limb, this one here, is going to be x is equal to 3 take away root 1 minus y. And what we can do is rotate those around the y-axis. And we'll do the volume produced by the outside one, take away the volume produced by the inside one. Now when x is equal to 3, if we substitute into there, we get negative 9 plus 18 take away 8. So that means the height here is 1. So what we're going to do is pi times the integral from 0 to 1 of 3 plus root 1 minus y, all squared dy. That will give us the volume for the outside rotated around the y. And then we'll take away pi times the integral from 0 to 1 of 3 minus root 1 minus y squared dy. Okay, so let's continue on with that. So we have pi times the integral from 0 to 1 of 9 plus 6 root 1 minus y plus 1 minus y. Take away pi times the integral from 0 to 1 of 9 take away 6 root 1 minus y plus 1 minus y dy. And we can see here those 9's are going to cancel out, the 1 minus y's are going to cancel out, and we end up with pi times the integral from 0 to 1 of 12 root 1 minus y dy. And so that gives me pi, let's put the 12 out here, 12 pi times the integral from 0 to 1 of 1 minus y to the half dy. And so that is going to give me 12 pi. So 1 minus y to the 3 over 2 divided by 3 over 2 times negative 1, with the negative 1 being the differential of the inside function there, evaluated from 0 to 1. So that's going to be 12 pi times 2 1 minus y root 1 minus y over 3, and we've got a negative in front of that. Okay, so 12 pi. Now, with the top limit of 1, we're just going to end up with 0. So it's negative and then 0. Take away and put the 0 in there, and we are going to get 2/3. And so it is just 12 pi times 2/3, which is 8 pi cubic units. But which way was the simpler?